Hello everyone, welcome to our webinar on continuous business learning. This is Zehra Çataltepe, the co-founder of Tazi AI, where we help businesses continuously learn from data and build machine learning systems that learn continuously from human and from data at the same time. So today we are going to talk about how to use continuous business learning and what is continuous business learning. We have a team of experts with industry experience and systems experience in machine learning. And our team also has a business part and offices in San Francisco, Amsterdam, and Istanbul. Tazi has been named the next generation of automated machine learning by Bill Burries and also by all other good people like Paco Nathan and Bob Cohen. These people also liked our solution. And today we are going to talk about why there is a challenge with AI, the way AI is implemented today, how we solve it using our continuous business learning approach, what are the components and benefits of CBL. We'll also go through a sample use case and demo and finish the presentation. So everyone knows that machine learning has a huge promise. By the way, I'm going to be using AI and ML interchangeably during the presentation, but they don't mean the same thing. So everybody knows that AI has a huge promise. McKinsey estimates potential of increased business in terms of trillions of dollars, and billions of dollars are expected to be spent. And furthermore, the expenditure and the use of machine learning is supposed to increase, and machine learning also is supposed to result in increase in jobs and profitability and productivity. And furthermore, we also know that data changes fast. So machine learning is supposed to deal with this change in data also. On the other hand, when I consider, for example, all the machine learning projects that I have done so far, up to Tazi, of course, we realize that the challenge in AI projects, in machine learning projects, is the retention problem, which means you create a machine learning project, you have a really good solution, and then as the data keep changing, you realize that your solution doesn't perform as well as it has performed before because it is not able to cope with the change in business and in the data. And there is also the problem of how are you going to align the business and the IT and the data scientists. There is a huge gap and culture difference usually between all of these parties, and it's hard to bring them together. Also, they are very busy. How are they going to align? And also, there is the shortage of data scientist problem, which becomes an important issue, more important issue every day. Gartner has a solution for this change. That solution is called Continuous Next. That vision says that dynamism will need to be one of the things that organizations will need to deal with, and organizations will need to be dynamic. And what we are especially interested in is this augmented intelligence part, which says that machine learning and people will be working together. And there are other parts of Gartner's vision, and we actually at Tazi have implemented this vision with our continuous business learning. What we mean by continuous business learning is an approach to machine learning implementation, which is business-centered and which involves a different type of machine learning, which is continuous machine learning. First of all, our approach to machine learning is business-centered, which means we provide a solution around business KPIs. The aim is not to optimize an accuracy or some other machine learning performance measure only, but business KPIs. We also believe that machine learning systems should be understandable by business because if business understands them, they own them and support them, and without business support, nothing can really be either useful or live long in a business environment, of course. Understandability brings actionability. So business actions are determined much better if machine learning is understood. And also business benefits can be estimated once we know that they are targeting certain business KPIs. Our continuous machine learning approach, on the other hand, contains machine learning models which are updated continuously, automatically, so that while the world changes, machine learning models are updated without requiring human intervention. We have to have robust models because as the world changes, if you have a single model, it may not perform well. So by inclusion of multiple machine learning models, we are able to cope with change. If one model fails, another one might be actually performing well, and we use actually ensembles of models where models take different roles in the decisions. Furthermore, we have other features like using different kinds of features, feature engineering, selection, and finally hyperparameter optimization, which allows us to automatically select machine learning parameters. Any machine learning implementation needs to have these 4 components. Of course, data and platform and algorithm is very well known by everyone. What we see is, in addition to amount and cleanliness and reliability of data, availability also is an issue due to regulations, for example, or maybe the speed of the medium which delivers the data to you. The data may or may not be available when you need it for machine learning. The platform or the algorithm has to be suitable for what you are trying to do. It has to be easy to use, and also we believe that machine learning platforms have to be understandable and actionable. KPIs have to be clearly defined, measurable, and also they have to be in line with the existing business processes. This is also an important point, because if machine learning tries to change the world completely, that may or may not work, because people may not be able to cope with a huge change in their business practices. And finally, the human is, of course, a very important part of a machine learning implementation. In addition to data analyst or engineer, or the machine learning or data scientist experts and IT, we believe that human domain expert always has to be a part of the machine learning implementation. So in order to be able to have a successful implementation, you need business expertise, working with people who have programming skills, math and statistics. You have tens of skills required, and our answer and our solution for a successful machine learning implementation is machine learning deployment is TASI, where we implement continuous business learning, and we make the data science teams much more efficient, and even business analysts are able to deploy, maintain, and create machine learning solutions. And TASI always works with a business expert. We believe that business expertise really cannot be replaced by anything. This is our system overview. We are able to process different types of data, heterogeneous data types, and our systems are automatically fed from streaming data. We have these 2 parts which form our automated machine learning part. We include feature cleaning, engineering, and selection, which allows us to process data faster, and also include business people in creation of new features. We also have self-optimizing learning or hyperparameter optimization, which reduces the data scientist time spent in finding the right parameters of machine learning. We have our core set of machine learning algorithms, which are always continuously learning, and except deep learning algorithms. These are all produced at TASI. And we also have these two components which form our explainable and human-in-the-loop machine learning. Machine learning system always explains what it does with explanations and confidences for every instance. And the domain experts can give feedback to machine learning algorithms through easy-to-use interfaces. And this is what we have right now. This is here we show some of our screens where the user is able to do feature engineering and selection, and here he or she is able to continuously monitor a running machine learning system, and here the model explanations and the human in the loop, the feedbacks are provided. Our architecture is able to support not a single but a set of machine learning systems serving different business KPIs. This is called enterprise-wide AI by some people. And this way we are able to solve not only one problem, but a set of business problems using machine learning. These systems could be feeding each other to help them get better results. Why do we need continuous machine learning, and why do we need human-in-the-loop learning? Here we see a scenario comparing batch machine learning, where you might get a very good data scientist team and great data. You optimize your machine learning solution, and you fit this, which depicts the world through your machine learning algorithm. But when the world changes, your algorithm still says the same thing, and there is this difference, which is the error, which is proportional, usually proportional to the business KPI that you are losing, the benefit that you are losing because your machine learning is behaving differently from the real world. And when this happens, when the machine learning algorithm is not correct anymore, the business realizes that it is wrong. It informs the machine learning or data scientist teams. They have to wait for more data and then train the algorithms, ask the business for checking it, and then deploy it and test it. And this can take a long time. The way we address this problem is continuous machine learning. Our continuous machine learning automatically adapts to change. So when the world changes, as the data is accumulated, our machine learning learns from the data. And this can be done without human intervention. In addition to continuous machine learning, we also provide learning from human expert, which is also called human in the loop. If the business person realizes, if the domain expert realizes here that there is a change that's about to happen, he or she can update our machine learning system. The machine learning system is able to adapt to change much faster thanks to the input that it gets from the domain expert. And this input can be provided by the domain expert even if he or she doesn't know any machine learning. He or she just needs to know his business. Here we want to show the value of our components, continuous learning. We show a real experiment where with one of our customers, we use churn prediction we use machine learning for churn prediction for financial investments. And here you see that a batch machine learning system which has been trained using a popular machine learning tool performs well at first, but on the y-axis we show the accuracy. Performs well at first, but then as the data changes, it degrades in performance. On the other hand, our machine learning system, which continuously learns, has more accuracy than the other system over time. And this difference corresponds to about $1.5 million a year over a total of $40 million a year revenue. So here we are showing our machine learning, the continuous machine learning's benefit compared to another machine learning. So this is better machine learning than the other one. Continuous learning enables us to get faster learning machine learning systems. Here again, we show another popular machine learning tool and on a decision tree implementation, but a batch decision tree implementation, shown in red. As the number of instances in the training set increases, the batch machine learning takes longer and longer time to train, but our continuous machine learning algorithm takes much less time, and as the data size increases, the increase in training time is much less. And we have seen up to 100 times speed up when we use continuous machine learning. And this is the comparison of using human in the loop versus regular machine learning. When we use human in the loop for network intrusion detection, we have seen that the amount of data required to have the same accuracy can be reduced by 3/4. So you just need 25% of the data that you would need for machine learning. And human in the loop is the future because according to different industry reports, decision support systems will be very important in the future, and human in the loop is an important part of that. Our solution has been compared to other automated machine learning solutions, and we have ranked high in terms of 4 categories: data processing, feature engineering, modeling, and visualization. This is a study from Target-Base. You can find it at this address. And Bill Voorhees of Data Science Central has called us the next generation of automated machine learning. We are very excited to be the next generation of automated machine learning. We aim to provide different kinds of business value through our technology. We have seen a minimization of risk because humans are able to understand what's going on with the machine learning systems. Through the value that we bring, new businesses, increased efficiencies, and other business values are observed. This is how we work with our customers. Before our engagements, we make a project plan and understand what the business KPIs are actually. And then we do an agile implementation where there is understanding of the data part and also the business analysis, a model implementation, and integration and testing, and then continuous learning process system is implemented through our technology. I want to talk a little bit about our use cases. Some of them are on our website, and we have used our technology in different industries, in banking, financial services, telecom, retail, and here are some details of those cases. In finance, we used TASI for card copying fraud detection, which is actually a very difficult type of fraud to detect. And we have seen that we are able to detect anomalies which are very rare. And we used past transactions on credit cards, and we have seen that we are able to detect card copying frauds with up to 95% accuracy. In insurance, we are working with our clients to detect and predict growth. So insurance companies work in different micro segments, and in some of them, through their actions or through the changes in the environment, they might have more or less policies. And the insurance companies want to know where they grow or shrink, and whether they are profitable or not at those micro segments. Our solution took information about not only the policies and the customers, but also the market and the competitors. We looked at different definitions of growth within a year or a month, and our machine learning system was able to detect patterns which were not detected by the actuaries by themselves. In retail, we used it for we used our system for clothing retail demand prediction, and in this case, the company had a lot of returns because items were delivered, but they were not sold, up to 55%, which is huge. And if an item is not sold, it would have to be sold at a very reduced price or returned. And there is a dynamical nature of customer behavior, and also the products keep changing all the time. So on a subset of 4 different categories, including color information, we were able to actually have up to 9% more better results than actual human allocators. And this results in millions of dollars of revenues. In telecom, we used our technology for campaign response prediction. Everybody gets SMSs to their phones. And I'm sure everybody's tired of them. So the hit rate for these SMSs were around 2 to 3%. Again, using Taz's continuous learning technology, we were able to find out who would accept an offer and who would not, with 61 to 72% accuracy, which is much better than the existing technology used by the company. And now I'd like to show a little demo of our system. Okay, so in this video, we show our system consists of 2 components. One of them is to be used by business analysts or data scientists to build a machine learning system. This system we call Tazi Deploy, and there is another component which we call Insights and Explore. And in this system, and a machine learning system which has been trained can be evaluated by the business experts. As I said, I'm going to give a very brief overview of both systems. First of all, in the Insights and Explore system, the business people can understand the performance of the models. Here we are predicting whether there will be high sales or low sales for a retail company. We show on the right whether the sales will be high in blue and whether they will be low in red. And we show the accuracy and the business value that can be addressed by the correctly classified instances. We sort all the instances according to their scores, all the stores according to their stores of being high or low sale. And the business actions can be planned according to where each store is. For every percentile in sorted order of the stores, we measure not only the hit rate, but also the benefit that can be acquired at that percentile. We also show the most important patterns or micro segments which show a certain behavior, and we decide on the importance based on the confidence of the classification algorithms and also the number of instances which exhibit the pattern. And the user is able to jump to a pattern through this interface. So not only the explanation for the single pattern, but also the patterns around it can be visualized here. Here at the top, you see the pattern or the segment description. So this store has low sales, and the stores that have these properties, which have smaller number of customers, has a large distance to the competitors, and the store has doesn't have a high sales score in the past, in a certain day of the week and the month has low sales. So the user is able to do different actions like diving deeper into models and filtering the models. I am going really fast, okay? And also the user is able to see the important features. It's possible to see which instances happen. The user can even take actions through this user interface. And I also want to go through our Tazi Deploy interface. Tazi Deploy allows a data scientist to deploy models much faster, and also even a business analyst or a business person to create new models. This is the entrance screen. Here we are creating an instance. Think of an instance as a set of models which serve a certain business purpose. Here we are trying to predict sales as we have done before, but this will be a different kind of prediction where we are going to predict not only high sales but high, low, or neutral three-class problem. We create an input source which can be a file or a database. So we import the file here, okay? And we also define the output. We can read from a file or a database and write to a file or a database. And now we are going to be creating a run, which is a specific machine learning system. And we just need to provide the input and the output. Now we are going to give a sample input file. We say what the delimiter is in our file, and as soon as we do that, our system automatically detects what type of inputs have been provided. So some of the instances are strings, some of them are integers. Their types will be automatically detected. And the user can say if the features have null values, whether there should be imputations. The user can identify what the label is. Here we are trying to predict the sales, whether some features will be ignored or not. These all can be given to the machine learning system through this interface. And the user can also look at the data details using our data profiler. Data profiler allows the user to find out the relevance, entropy, the statistics, whether there are missing values or malformed values in the data, so that before the data goes into machine learning system, it is checked and precautions are taken through the changes in the schema, and different types of labels and label weights can be defined here, and machine learning models can be selected with different parameters. Here we are using a decision tree and also a neural network, and finally there are other system parameters that can be set. After these, you have your run, and you can start your machine learning algorithm. So you just created a machine learning system in a couple of minutes, actually. So you start your run, and when it starts, you go to your web server to check how your models are performing, how many instances have been predicted to be what, and also the performances of different machine learning models, your overall model performance, and you are able to teach your system through instance feedbacks. You can evaluate different alerts, and finally, you can see if you have your data flowing right or not. If your machine learning system is misbehaving, you can see whether it's because the data is not being received, maybe. And at the very end, you are able to see the model explanation. So this model explanation will grow as it learns more from the data. The user can, you can stage your model, make changes according to your experience. This is the human in the loop part, and commit your model. So this is a very fast overview of our system. If you would like to learn more, please send us email to info@tazi.ai. And thank you very much for your time, for attending our webinar. And we hope to see you in the future at our other TASI webinars. Thank you.